Okay, guys, 6 o'clock on the dot. Time to get started with some maths for the day. Okay, can you guys all hear me? Can anybody hear me? Okay, Tristan is
Yeah, we
saying
can hear you.
no. Okay, thank you. Okay, perfect. Thanks, guys. All right, so if my voice does that weird thing where it disappears every now and then, please just bear with me because I've been lecturing all day and it continues now. So yeah, let's just go with whatever happens. If you hear a squeak, I'm not going to even bother trying to, not sound embarrassed and stuff. It happens, yeah. Someone talking to me. Oh, sorry, this is not your work. Okay, here we go. Okay, so I thought since last time it was so successful just going over an ICE task, because I think the principle here is we just keep on doing examples. It's quite a useful thing. So today I was looking at our timetable and I realized we have something like 12 sessions altogether, divided by 5 learning units. So more or less 2 learning units a session, right? With some change at the end. So if we can on one day focus on the examples from the learning unit and the next day focus on the ICE task, or some combination of things like this, then that's probably the best thing we can do, because explaining too much of theory is probably not the best. So yes, we're going ahead with learning unit 2 at the moment. And if you guys have any questions, comments, complaints, recommendations, anything, just interrupt me and let me know. My thing is not muted again today, so I can hear you guys. Also, let me apologize for not answering a lot of questions on WhatsApp. Things have been a bit hectic, and yes, I'm aware that the submission link has not yet been sorted out. I wouldn't stress too much about it though, because we have a bit of time, and I messaged someone, so they will get back to me at some point. But again, don't worry about it, because you have access to the actual task, the actual, questions. That's the main thing. Is someone talking to me? Hello? Is someone talking to me? I don't know. I'm hearing voices. Is someone there?
No, so you're all good. I think there's someone just joined with their mic unmuted.
Okay. Okay. All right. Thanks, Jared. Okay. All right. So we're just going to jump straight into some examples where we try to solve for x. And just give me a moment. Let me just grab calculator and keep it next to me, just in case we stumble onto anything a bit difficult. I don't want to waste time thinking in my head and possibly getting things wrong. Okay, so these are straightforward. I'm going to do these very quickly. Solve for x. The first example up here, 3x is equal to 24. So what we do for something like this is, well, not only for something like this in general, always try to isolate x and keep it alone on one side, right? That's the whole point of these solve for x questions. So to isolate x in the example on the top, we simply divide both sides by 3. And then on the left-hand side, the 3's cancel out, and you're left with nothing but x. On the right-hand side, we've got 24 divided by 24 divided by 3, which is 12, right? 12, 24, no, not 12, sorry. See, that's what I meant when I said my brain doesn't do these things. It's 8, right? 8 times 16, 24. You know what? Let me swallow my pride and keep the calculator here. Yeah, okay, there we go. Let's write that x a bit better. Okay, so remember, guys, I'm actually a physics person, not a maths person. So the quick maths doesn't really happen for me all the time. So just bear with me if I make a mistake.
Sorry,
Okay.
sir. Sorry to interrupt
Yes,
you.
no
So
worries.
I saw this while doing the ICE task, right? In the event that we've got an exam, and I just skipped the step where I divided those, like both sides by 3, and just jumped straight to dividing 24 by 3. Will I forfeit any marks in any way?
No, you wouldn't. As long as you show 24 divided by 3 before writing 8, that's perfect.
Okay. All right.
All right. Again, great question. I hope you guys all heard that. That's a good question. And if you're ever unsure, it's always good to show more steps rather than less, if there's ever any doubt. You can never lose marks for showing too many steps. All right, so this example here, we have a half x, which some people may know it says x over 2 is equal to 8. Some people like to do that. I also prefer to do that. Then you can multiply both sides by 2. Okay, and then the left-hand side, the 2's will cancel, and you're left with x is equal to 16. Okay. Again, guys, I'm just going ahead. If anyone needs to stop me, just do that.
Sorry, sir,
Okay.
can I stop you? With the
No?
previous example that you just went through,
Yep.
I'm a bit confused as to how we went straight to x over 2 is equals to 8. Is that by putting the half and multiply? Like, I don't understand how we got there.
So you're looking at the second step.
Yes, 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 this one. So
Okay.
the moment you got x over 2 is equals to 8, what happened for it to, yes.
From here to there.
Yes, yes.
Okay, all right. So yeah, maybe I shouldn't skip that. So what we have in the first step is this, and technically what this is a half times x, which is x over 1 on the left-hand side.
Okay.
Right? So the way multiplication works with these things is we just multiply the top and multiply the bottom. Okay, again, sorry, the pen does that every now and then. And then the top 1 times x is just x. The bottom is just 2 times 1 is just 2, and we have 8 here. So that was my starting point. I kind of skipped all of this.
Okay. So seeing that this question is more complex than the one we did before, will I lose any marks if I took your direction as well with this one?
Just what I did here.
Yes.
No, you wouldn't lose any marks.
Okay. All right, so understood.
All right, perfect. Yeah. Yeah, guys, it's always good. Keep the questions coming. Don't ever sit with doubts. I appreciate it. Okay. All right, guys, I think someone's mic is unmuted. I can hear what sounds like BBC News in the background. Yeah, just check what Trump is doing and let us know. Okay, anyway, forget about that. We don't have time to mess around. Something like this example, usually what you guys would do is, what's the word? Cross multiply, right? There's a few different ways to do this, but cross multiplication is always safe. Let me just think whether I should. Okay, no, let me not do anything funny. Cross multiplication just means on one side I will write 10 times 7. There's a negative there, so let's attribute the negative to the 7. Okay, I can put the negative up there if I want to. I could also put it, if I put it up there, then I must take out the negative from here. See, if there's a negative in front of a fraction, you could have the negative on top by the 7 or at the bottom by the 2. It doesn't matter. That's completely your choice, and you will get the same answer either way. So that doesn't matter. Okay, so I chose to put it up by the 7. Again, doesn't matter. So as I'm saying, to cross multiply, we take the 10 multiplied by the negative 7 on one side, and we get negative 70. On the other side, we take the 2 multiplied by the x, and we get 2x. That's how you cross multiply. Okay, and sometimes it's nicer to write it the other way. Instead of this, we write it as 2x is equal to negative 70. These two lines are completely equivalent. It's just nice to write the x on the left. But again, that's up to you. So from here, we can just divide both sides by 2, and here we get negative 70 over 2, right, which is negative 35. So there's your answer right there. Okay, so that's how you deal with something like that.
Sorry, so I just want to ask
Yes.
a question. So we are
Sure.
allowed cross multiplying over equal sign, hey?
Yes, you can do that. Perfectly fine.
Okay.
Okay. Another way which I could show you guys if you're interested is to just multiply both sides by 2, and you see you'll get the same answer. So if I take negative 7 over 2 is equal to x over 2, and I multiply both sides by 2, the 2's on the left cancel. This was a 10, right? Yeah, that was a 10. So the left, we are left with, on the left, we are left with a negative 7. On the right, we are left with x over 2. So negative 7 is equal to, this can be written as x over 5. right? If you want to see that step, that's because you can write x over 10 times 2 as x over 10 times 2 over 1, and multiplication commutes, so you can move things around and write it as 2 over 10 times x over 1, or just 1 over 5 times x over 1, which is just x over 5, right? That's unnecessary extra stuff, but if you wanted to see that, that's what happens there. And now from here, we can just multiply both sides by 5. Again, sorry guys, I'm going a bit quick, but all of this will be in the video if you need to slow it down, or stop me if you need to. Okay, so multiplying both sides by 5, cancel the 5s out on this side, and on the left we have 5 times minus 7, which is just minus 35. So same thing, right? Another way to do the same thing, there's probably many more ways to do these things, but I'm just showing you guys some of the basic ones. And of course, there's too many examples here, so I'm not going to go over all of them. We'll try to get through this as quickly as we can and maybe start the ICE task today. Okay, but if I skip over something that you guys really want to see, just stop me and I will go back to it. Okay, but also guys, something very helpful for maths is if you want to try these by yourself and you're not sure of the answer, if you put these directly into ChatGPT and say solve for X, it does it for you perfectly. So it's a nice way to check your answers, and it'll give you working step by step as well. So it's always worth trying these by yourself and getting those instructions from ChatGPT if you feel like you need them. Okay, this is one, again, you guys can try this one at home. This is same principle, just we have decimals involved here. So this becomes more calculator work. Okay, I'm just curious, does anyone want me to do this example? Just give me a show of hands if you want to see this one. Okay, hands are going up. So let's do this one. Okay, so I'm going to cling to my calculator here for this one, just as you guys should. Okay, so here we're solving for y in this case. Doesn't matter what we call the variable. We have 3y. I'm not going to rewrite the question. I'm just going to bring all the y's to one side and take all the straightforward numbers to the other side. So I'm choosing to bring all the y's to the left. We have a 3y on the left already, so I'll scratch that out because I'm done with it. Then I'll bring the 2.5y to the left. Because I'm moving it over the equals to sign, I must change its sign. It becomes negative 2.5y because I moved to the other side. And now on the right-hand side, I have a 6.5y, which already lives here. All right, scratch that out because we're done with it. Then I need to take the 10.5 from the left to the right. So in doing that, I must change its sign. Remember, you can move anything to any side. If you move it to a side, if you move it to any other side, you must then change the sign. Anything. That's how these equations work. Okay, so on the left now we have 3 minus 2.5, and I'm pretty sure I can do that one in my head. 0.5y. And on the right, we have 6.5 minus 10.5. Again, this one is not so bad, I think. Minus 5, right? Yeah, that's minus 4. Okay, and at this point, we can just divide both sides by 0.5. So let's do that. 0.5, 0.5. On the left, the 0.5 cancels out, and we're left with y. On the right, we have, again, don't be afraid to use calculators for these things. Negative 4 divided by 0.5 should be the same as negative 4 times 2. Let me just check that because I'm always skeptical. Yeah, so that's minus 8. Okay. All right, so I hope you guys are comfortable moving things around in these equations. And again, yeah, we will see more complicated examples in the ICE task. So for now, okay, we got some more complicated too as well. Maybe I should go to the last one. The last one is usually the most complicated. So let's try this one here at the bottom. This one looks like it could be a little bit tricky. Yeah, okay. Here we're solving for A. So they wrote a 3 squared at the look more complicated, but we don't need to be fooled by that. We can rewrite the left-hand side as 2 plus A over 2, all over 2, right? and the right-hand side is just 3a plus 4 over 9. So now it becomes a simple cross multiplication problem. I should be tentative in saying simple because if you haven't seen it in a while, it could be a bit tricky until you start getting used to these things. So let's get acquainted and get comfortable with it. Cross multiply on the left, we will write, no, that doesn't look good. Let's change color for that. We will write 9 times that, and on the right, we will write 2 times that. So let's do the left first. We have 9, 2 plus a. On the right, we have 2, 3a plus 4. Now the brackets are important here. It tells me that the 9 multiplies by everything within the brackets. So on the left, we get 18 plus 9a. We distribute the 9 into the bracket. So it's 9 times 2. First, 9 times 2 gives us 18. Then 9 times a gives us 9a. On the right, we do the same thing. 2 times 3a gives us 6a. 2 times 4 gives us 8. Okay, now same idea as before. We now need to bring all the a's to one side. We always, by convention, choose the left, but again, that's up to you. So I like to bring all the a's to the left. So I'll write here 9a minus 6a because I pulled 6 from the right. And the right already has an 8. From that, I want to subtract 18. Okay, so now we have a 9 minus 6 on the left, which is positive 3a. On the right, we have 8 minus 18, which is just 10. No, minus 10, sorry. Yeah, okay. And now all we need to do is just divide both sides by 3, because 3 is the coefficient of the variable of a. Okay, so let's do that up here. So a is equal to minus 10 over 3. Now, can that be simplified further? Probably not. 10 is not to, yeah, so we should just leave it like this. You could write it as a decimal, but that's always a bit messy. So it's nice to leave things as a fraction or as an improper fraction or mixed fraction. Again, that's up to you. Okay, I'll just leave it like this. All right.
Sorry, so like
Yes.
for that one, can we solve using a common denominator?
Yes, that is the other method. You can do that. That's perfectly fine.
Thank you.
Okay. All right. Yeah, so guys, if you want to practice as well, if you think of other methods, you can always try them and see if you get the same answer. It's always interesting to do that. Okay, so yeah, that's what this thing is saying up here. Regardless of which method, you should get the same answer. Now, why do we have these here? Okay, I suspect this is here for a certain reason. So let's do one of these, because now we know how to solve equations, but there are special cases with these equations where you might not have a solution, or you might have infinitely many solutions, not just one x. You might have more than one x or infinitely many x's. So we need to be able to identify these cases, and I'm pretty sure this is one of them. So let's see what happens here if we try to solve this naturally. I'm going to do the solving part quickly now because that's not the point here. So the left-hand side here, we have 2x minus 7x. Can I find another x on the right? There's a negative 5x. I'll bring it here as positive 5x. Now on the right, I want to have just the numbers. So here we have 5 minus 12 plus 8. Okay, so on the left, let's see. Someone has a hand up. Yes, feel free to speak if you need to. Someone's saying something. More recommendations. Okay, there's a question here for more recommendations. Let's see. There are textbook recommendations in the module outline. So those are usually good and consistent with what we're doing in the lecture stuff. So you could have a look at those if you want to. And I'm pretty sure they have links for PDFs as well. Yes, thank you, Jared. Past papers as well. Okay, which you can find on, pretty sure you can find that on VC Arc. I mean, sorry, not ARC. In the intranet under student material, probably it'll be somewhere there. But yeah, we'll clarify that and I'll let you guys know on WhatsApp. I'll go and check what's actually available. Okay. So where was I? Yes, I was trying to solve this equation to see what we get for x. You guys will notice here I have a 2 minus 7 plus 5 on the left, which gives me 0, 0x, which is a bit of a strange thing. Okay, and on the right, we have a 5 minus 12 plus 8, which is 2, 1. It's 1, right? 1. So 0 times x is the same as 0, right? 0 times anything is 0. So we end up with 0 is equal to 1, which is clearly a contradiction, right? This is a broken equation. 0 is not equal to 1, so this is not true. So if you ever end up with a statement which is not true, it doesn't have to be 0 equal to 1. It could be anything equal to anything. It could be, like, for example, 5 equal to 7, whatever, as long as it's something which is not true. So if you get something like A is equal to B, where A and B are different, then we say there is no solution. So we need to be able to identify this case. So anytime you get a false statement, so this is a false statement. Whenever you get a false statement, it means there is no solution. Okay. And this usually takes the form as 0 is equal to something. All right. So you guys can practice with this example at the bottom. It's going to give you probably no solution as well. All right. So yeah, here's a summary of what we just said, or restatement. Now this is probably going to be the second exception to the rule that we learn here, but let's see what happens. Let's try to solve this equation above. 5x minus 4x on the left, minus 4x, and I can pull the other x from the right, minus x. On the right-hand side, we have a 3 minus 3. So here on the left, we essentially have 5 minus 5, which is just 0x. On the right, we also have 0. So this tells us 0 is equal to 0, which doesn't give us anything for value of x. So it's not exactly what we're looking for, but this is a true statement. So if you ever get a true statement which tells you nothing about the variable, then there are infinitely many solutions. So if you get a true statement which doesn't tell you anything about the variable, then there are infinitely many solutions. Right? So to have infinitely many solutions means in the original equation, I could plug in any value for x, and the left-hand side will always equal to the right-hand side, which is a bit of a weird thing, but it's true, and you guys can try this at some point if you want. Plug in any value for x into this equation, and you'll see you always get left-hand side equal to right-hand side. Okay, so this equation here is equivalent to writing something like x is equal to x. No matter what you do, this equation is true. No matter what value of x you plug in here, this equation is true. Okay, and the one above that we just learned where there's no solution is essentially a broken equation. It's like you have x is equal to x plus 1, for example. No matter what you do, you cannot make this true. Just a practical example, because x cannot be itself plus something else. That doesn't make sense. Okay. Okay, so now we need to go to inequalities. And let's see what we are doing here. Solving inequalities is pretty much the same as solving equations. We just have to be careful for one thing.
Sorry, sir. Sorry.
Yes.
I just have one last question.
Sure.
In terms of when we solve for x and there's an equal sign, you did say that
Okay.
once it comes across, it becomes opposite. Does that work for square roots and exponents as well? So let's say they
Uh,
gave us x to the power of 3. Does that make it a cube root or like somehow like if we'd have to work with that?
or if you want to move the x cubed to the other side, you mean something like
Basically,
this.
yes, yes.
Okay, so what would happen is this will then become 0 on this side, and this will become 1 minus x cubed. Yeah,
Oh,
so
okay.
Yeah. So it's always opposite in terms of plus and minus. All the
Okay.
other operations don't change.
All right. All right.
Okay. Excellent. All right. Yeah, guys, keep interrupting me if you need to. I like knowing that you guys are engaging. Okay. So solving inequalities. Here we have to also graph solutions, which is one of the easiest ways to get marks. It's like free marks. So I'll show you guys with a simple example. X plus 3 less than 5. And let me actually show you guys two things in one go. Yeah, so let me change this example and make it negative x plus 3 is less than 5 because we learned two useful things here. So now just like in an equation, we write this as negative x less than equal to 5 minus 3, or negative x is less than equal to 2, right? But now we want x alone on one side, not negative x. So to do this, we could either multiply both sides by -1 or divide both sides by -1. It's easier to just multiply both sides by -1, so I will do that. And then on the left, we get -1 times minus x, which is just x. On the right-hand side, we get -1 times 2, which is -2. Now the rule here is whenever you multiply by a negative number or divide by a negative number, then the inequality sign changes. So less than becomes greater than. So whenever you multiply or divide by a negative number, then the inequality sign changes. That's the only difference between this and an equation in the way you'd solve it. Okay, so once you have your solution, all you need to do is just plot a number line, really. And this is the easiest thing to do in the world. You just draw a number line. I'll start from here, 0, 1, 2, 3, 4, and so on. -1, -2, -3. And to do this, we will then go to our solution, which is -2, draw a circle. I'm drawing an opened circle because the solution is greater than -2. If the solution was greater than or equal to -2, so if the solution was like that instead, then instead of an open circle, I will draw a circle and then color it in. Right? That's the only difference between greater than or greater than equals to. And it's the same with less than or less than equals to. Okay, and now once I've circled the solution, we then follow the direction of the arrow of the inequality. So the solution is x greater than -2, so it points to the right. So I must draw an arrow pointing to the right all the way to the end of the graph. And that's the plot of your solution. It's as simple as that. Okay, let me pause here for a second to see if any questions come up.
Sorry, sir. Is this something
Yeah.
that we would be expected to do maybe in an exam, like the number line?
Yes, this comes out pretty much every year,
Okay.
right? Yeah, and this comes up for a good amount of marks as well. So you could sometimes even get up to 5 marks for drawing these graphs. That's a fair amount for not a lot of work. Okay, so yeah, bank on these marks.
Hi,
Sorry,
sir.
so
Hello.
when you get those greater than and
Just
equal to, all of that stuff, is that when we know we have to draw the line?
Yes, whenever you see an inequality, then you have to, but they will always tell you in the paper whether you need to plot it or not. If they don't say plot it, then don't worry about it.
Okay, no, that's perfect. Thank you, sir.
Okay, you're welcome.
sorry, sir.
Yes.
Just want to ask on the number line, do you have to draw the dot and the line on top of the number line, or can it be on the top?
Yeah, you can draw it at the top. So I know some people prefer to draw it up here instead of on the line. That's perfectly fine. You can do that if you want to, no problem.
So I heard nothing. I don't know if it was my network or
Oh, sorry. Can you guys still hear me?
yes, I can hear you now.
Okay. Okay, so as I was saying, some people number line on top, sorry, the solution on top of the number line instead of on it, like this. That's perfectly fine. If that's what you prefer, you can do that. Okay, just testing. You guys still with me? Can you guys still hear me?
Yes, sir. Can you hear perfectly?
Okay, all right. Thank you. Okay, 6:30, we're about halfway done, and we are not too bad from where I'd like to be. So again, I'm skipping through a lot of examples, which you guys can try at home. And let's see. Be careful with multiplication and division. Yes, I've just given you guys this little disclaimer here. So we spoke about dividing, multiplying by negative sign. So as always, let's just go to the last one and see if it's a bit challenging, maybe a bit interesting. But again, this is very similar to an equation. So should I? Okay, let me try and do this relatively quickly, not to waste too much of time. Okay, so the left-hand side, I'm just going to open it up by distributing the 3/5 into the brackets. So maybe I should show this a bit carefully. Let's get the blue color for this. This becomes 3/5 times 2d minus 3/5 times 5. That's the left-hand side. Right-hand side, we can distribute the 4. So 4 times 7, 7, 14, 21, 28 minus 4 times not a quarter, 4 times negative 1/5, which we can just write as 4/5d. Notice on the right, I didn't show as many steps as on the left because I'm hoping people are following that step. But again, stop me if you need to. Okay, so on the left now we can simplify this as 3 times 2d on the top for the first term. So that will become 6d, and the bottom is still a 5. Okay, because remember 2d is the same as 2d over 1. So at the bottom you get 5 times 1. Okay, and this other term here, the 5 cancel out and we're left with just 3. Okay, less than equal to 28 minus, we can write this as 4d over 5. Maybe that looks better. Okay, now getting the d's to one side, 6d over 5 plus 4d over 5 less than equal to 28 plus 3. I hate numbers like this, but anyway. 6 plus 4 gives us a 10. Maybe that's not so bad. Over 5 less than equal to 20. Yes.
Sorry to cut you. How do we get to 28 on the right side?
7 times 4 because I
21.
distributed the 4. Is that 28? Did I mess up? 70.
No.
Let me just double check. You guys are stressing me out now. Is my maths failing? 7 times 4. Yeah, I'm getting 28 for 7 times 4.
My mistake.
Okay, that's all right.
Sorry, sir. Sorry to disturb you.
No worries.
Anjana, how did you get the -3?
Minus 3. Oh,
Yeah.
okay. So that came from the second term in the distribution. So let me just take out what I canceled. Yeah. So the first term, we distribute 3/5 into 2d. That leads to this term at the bottom here. 3/5 2d. Then the 3/5 goes into -5. That's how we get this term down here. 3/5 times 5.
Oh, I see. Okay. Thank you.
Yeah. Okay, no problem. Okay, so let me just recancel the 5 so we know they cancel out. Okay. So I was at the bottom here working out a 28 plus 3 and stressing about it, and I think that's going to give me 31. Yeah, okay. So from there on the left, we can just simplify 2/5 as, sorry, why am I saying 2? 10/5 can be simplified into 2. So that just becomes 2d on the left, less than equal to 31. Okay, now we just divide both sides by d. Saying the wrong thing. We divide both sides by 2, and left with d is less than equal to 31 over 2. Okay, so that's the solution. But now to plot this, it sometimes is helpful to write it as a decimal or a mixed fraction. So decimal is always easier because it's just straight up calculator work. 31 divided by 2 can be written as 15.5. Or if you prefer to write it as a mixed fraction, you can write it as 15.5. Either of these three are perfectly acceptable. All right, so in case I'm losing anybody, you write this as 13/2, or you write this as d less than equal to 15.5, or d is less than equal to 15.5. Now the second two options make it look much easier to plot the number line. So again, to plot the number line, you don't have to always start from 0. You can start from anywhere as long as you show 2 points on either side of the number. So 15.5 for that, let me start somewhere with, I don't know, let's say 13. So let me put a 14 here, 14, 15, 16, 17, 13, 12, right? Again, as long as you can show a few numbers, it's good enough. So 15.5 will be somewhere here. And now we have to color the circle in because it's less than equal to, right? So less than equal to means the arrow is pointing to the left. So I'll just color it in here and try and be neater than I am. This is very bad. But yeah, that's what you do. Okay. So there was two things we did, is inequalities and plotting the solution. So what else? Let's see if there's anything else here that I missed. No, okay, we're good. So now we look at absolute value equations. So here I could try to explain to you guys the intuition behind what's happening, but I don't think we have enough time for that. So let me just show you guys a method which always works, how to solve these equations. So if you have an absolute value equation, firstly, we know absolute value means it always outputs a positive, right? So if we just look at this, absolute value x is equal to 5, we can see immediately if x is equal to 5 or if x is equal to minus 5, in either case, the equation above is true. If I plug 5 in, absolute value of 5 is just 5, so that's fine. Absolute value of negative 5 is also 5, because remember, absolute value just gives you the positive version of something. So both of these are the solutions, but how do we actually get there? And that is by considering what it's written here, the positive and the negative version of a solution. So we always start like this. We take the original equation. So this is my starting point right here. Let me just rewrite this as a starting point. We take the positive version of the absolute value, which is just, you can write positive x is equal to 5, but positives usually don't show. We'll just write it as x is equal to 5. Then you take the negative version, which is negative x equal to 5. Right, so these are my two equations. And if I solve these two equations, I get the solutions. And the first one is already solved. We don't have to do anything. There's not much more to do. The one on the right, we can multiply or divide both sides by -1 and get x is equal to -5. So that's the second solution. So this was a very easy example. That's all you'd need to do. Note also that when I say take the positive and negative version, that only applies to the absolute value part. Everything else, you leave it alone. Like, see the 5, I didn't change the sign in both cases. Did I just not admit someone? Oh, I hope I pressed the right button there. I hope I pressed admit. Okay, but if not, I hope they try again. Okay, so let's try another two examples here. Maybe let's just go straight for the second one. It's a similar idea, and the second one gives us more information. So solve for P. Okay, so here again, positive and negative version, and then you just solve both of those equations. So the positive version of this is just 2p minus 4 is equal to 26, right? There's nothing much to do there. That's a simple one to solve. The negative version is negative. The absolute value part is 2p minus 4 is equal to 26. Note I put a bracket there because that negative has to include both those terms in the absolute value part. So the brackets are important because now the negative distributes into the brackets. I'll show you guys that in a moment. The left one looks more simple to solve, so I will do this one quickly. This gives me 2p is equal to 26 plus 4, which is t. The right-hand side, so p is just equal to 15. Right, sorry, I'm going a bit quickly with these. Now the one on the right, I'll be a bit careful because the negative it's the same as having a -1 on the outside. Negative and -1 are the same thing. So essentially we're distributing -1 into both the terms. So that becomes -2p, and negative times negative is positive. So this then becomes +4 is equal to 26. Now it looks much more digestible. This becomes negative 2p is equal to 26 minus 4, which is just 22, or p is equal to negative 11. Right, the last step, I just divided both sides by negative 2. And that's it. That's your two solutions. Okay, so always note the positive and negative version. That's the hard part. After that, you just go about solving these equations like you did before. Michaela has a question. Hand is up.
I would like to ask for the absolute value. Is it whatever is in the bracket must be negative, or is it just the p must be negative? So it's all for p. Just the p must be negative, or the entire thing in that
Okay, I got you. So that's a good question. It's always everything within these two lines that must be positive and negative, not just the p. Okay, so essentially you put a negative sign on the outside of that and keep that part within brackets. Okay, yes, Jared.
So just to make our lives easier, I know I've learned this from like school days, is like you get the formula for this. So in the absolute value is A, then it's equal to B. Can't we just use the two solutions that it's like A equals B or A equals negative B? I know it works out the same in the long run, but I know it's quicker just to do the formula way.
Does it
I
work
did,
with the same? I'm
I
not
did
so
post the formula in chat if you want to see it.
Yeah, maybe we should look at that at some point, because if I understand you correctly, you're saying, like, for example, if I get the solution 15, then the other solution is going to be minus 15.
Okay, so no. So like what I mean is, so the left side is correct. So you see where you implement the negative with
Yeah,
the
right. Yeah.
brackets. Instead of doing the whole negative with the brackets, you just take the negative and straight up put it to the 26. It will still give you negative 11. And it like cuts a step out.
Yes, actually, you can do that.
That's what I'm saying about
Yeah.
like the formula way. Because the formula way makes the negative move to like where the 26 is.
Okay, yes, so that's perfectly valid. And if you guys want to use that, you can use that. But I'll show you in a moment why I started avoiding that approach. Again, I'm not against it. If it works, it's perfectly valid. But I'll show you a case where you need to be a bit careful of that rule. Okay, but I appreciate it, Jared. I always appreciate another method to do something. So actually, here's an example here where we need to be a bit careful of that rule. But if you are careful and you know what you're doing, then you're fine. You can use that rule. Don't ever be afraid to use something you like, as long as you know how to use it properly. Okay. So in this case, what I've seen happen so often, guys, please note what I'm writing now is incorrect. I'm showing you a common mistake. So please don't take it down and say my lecturer told me this is right. No, okay, this is incorrect. So let me write in an uglier color to show it's incorrect, like a Shrek kind of green or something. Okay. Oh, sorry, that's just not right. We can't see that clearly. Dark green. Okay. So if I take this example, the positive version you would think is going to be 3, 4w minus 1 minus 5 is equal to 10. And a mistake used in the method Jared talks about is to take the negative version as 3, 4w minus 1 minus 5 is equal to minus 10. Right? If you did that, it would actually be incorrect. And the reason for this, so I'll just mention that's not correct. The reason it doesn't work here is because if you want to use Jared's method, you have to first isolate the absolute value alone on one side, and then only you take the positive and negative version, right? So maybe we should check doing that whether we get a different solution. Actually, I know we will because I've tried this before, but let me show you guys what I mean. Let me show you the correct way to do it instead of emphasizing too much of this method. And then I can show you guys, if you're interested, if there's demand for it, how we can correct this method for this question. Okay, so here we just isolate the absolute value on the left-hand side. So we first move the 5 to the right and we end up with 3, 4w minus 1 is equal to 10 plus 5, which is 15. Then we divide both sides by 3. Now, often some people will multiply the 3 into the absolute value. We shouldn't do that because absolute value is not like a normal set of brackets. Things can get messy. So in general, just leave the absolute value alone and move everything else to the other side. It's always safer. So 4w minus 1, I divide both sides by 3. Let me write this in brackets, divide by 3. And then we end up with a 5 on this side. Now we have something that looks familiar to us. We've seen these above. And from here, if you use the method Jared just mentioned, you're completely safe. Nothing can go wrong here. Okay. So in fact, maybe we should do this one using that method. Why not? So the positive version is 4w minus 1 is equal to 5. The negative version, according to Jared's method, is 4w minus 1 is equal to minus 5. Perfectly valid. You will end up getting something correct if you do this. Okay, so let's work with the one on the left first. This becomes 4w is equal to 6, or w is equal to 6 over 4, which is just 3 over 2. So 3 over 2 is the first solution. On this side, we have 4w is equal to minus 5 plus 1, which is minus 4, or w is just minus 1. Okay, so two solutions. Now, just to be consistent for those who want to remember the first method we used, up here, right, the positive and negative version using the old method would just be 4w minus 1 is equal to 5. That's the positive version. And the negative for the absolute value part, 4w minus 1 is equal to 5. Right, completely equivalent. This will work as well. Okay. And now, again, guys, if I'm losing anyone here, please don't stress about this. If all you learn is what I've shown you for the first attempt of this example, that's perfectly fine. But now, just to emphasize why the example went wrong when I did it with the first go using the method that Jared mentioned. Again, I'm not discrediting it. I'm just, mentioning a common mistake here. If you immediately take the positive and negative version, it must look like this. Positive version is 3 to 4w minus 1 minus 5 is equal to 10. That's the positive version. The negative version is just the negative of the absolute value part. So that becomes, there's already 3 on the outside, so we'll just take that as 3. See, negative 1 in front of the absolute value part, 4w minus 1 minus 5 is equal to 10. This is what the negative version looks like. Just a negative 1, or just a negative on the outside of the absolute value part. Okay, so this is another way to do it if you don't first get the absolute value part to one side. But yeah, this what we did right here is probably the easiest way to do it.
Sorry, so you see, this is why, like, if you do the formula way, like, they always teach you to, like, simplify the absolute first and get it by itself, and then only plug in the formula.
So
Because
up until this point.
Yeah, up until that point, and then only do you do the absolute value. Because the other way that you're showing us there up top, I know a lot of people get confused with that because they don't know where to actually put the negative in that whole
Yes.
solution when you're actually
Yeah.
only supposed to be putting it in front of the absolute. So that's why I mentioned the other method, which is a formula one.
Okay, so your method is down here, basically the easiest one.
It should be, because everyone knows to simplify the absolute before doing it. Because, I mean, that's the way I was taught in matric.
Okay, no, that's perfect. Thank you, Jared. And I will take that disclaimer and just mention to you guys, yes, please listen to what Jared is saying, which is what we're emphasizing. Keep the absolute value alone on one side before you take the positive and negative version. Then at that point, you can use the method Jared used. It's probably the better method. So go with that one, or you can use the one which we looked at above. It's absolutely equivalent, right? So again, you guys can try both, use whichever one you're comfortable with. That's all right. Okay, now let me see what we're looking at here. Absolute value inequalities. Okay, so now we're taking two things we learned and putting them together. All right, so I'm sure we can go over this in a little bit of time. I'm going to try not to waste too much of time here with things we already know. So absolute value inequalities is, again, the same idea where you take the positive and negative version of something using the rules of inequalities where we know if we multiply or divide by negative, you have to change the sign of the inequality. So to solve this one above, I am going to Again, we have to plot these as well. But now to solve this, I'll take the positive and negative version, which is just x less than equal to 4, or negative x less than equal to 4. Now let me just think for a second here. Something occurred to me. Yeah, so, okay. Again, Jared, I hope it doesn't sound like I'm dissing you when I say this. I know you're showing me a very valid method and that works above, but here I don't think it's going to work. If I think about it, if I use the method that he mentioned, which you guys probably learn in school, and I just put the negative sign
So
by the
with this version, you will have to flip that sign.
Yes. Okay.
Yes.
There's
That's
the
where the
disclaimer.
tricky part comes into place.
Okay.
That's why they say use the trick. But I guess it's all how everyone's taught. Do it your way. It's up to you guys.
Yeah. Okay. Couldn't have said it better myself. Okay, so again, here, whichever method you use, there's some disclaimer in either method. Yeah, so here, I'm just going to take the positive and negative of the absolute value part, and then everything else we'll deal with as it comes along. So the one on the left, the positive version, we see that's pretty much solved. We don't have to do anything to it. The one on the right, we just need to divide it throughout by a negative, or -1, and this just becomes x greater than or equal to 4. Okay, so it's not so bad. I mean, you guys will get the hang of it with a bit of practice. And plotting something, so there's one more step, possibly two more steps. First, you have to plot this thing. Very quickly, I'll draw an untidy number line. 1, 2, 3, 4, 5. -1, 2, 3, 4, 5. Same idea as before. Nothing different. You just plot the appropriate circle, colored in or not. This one here is colored in because it's greater than or equal to. At -4, or there should be a negative here, sorry, -4. Yeah, so one solution is -4, the other one is +4. And just as before, we follow the arrows. So the 4 is going to the left. So I'll start drawing a line to the left. I'm not going to close it in yet, and you guys will see why. The -4, the solution is going to the right. So these solutions will meet up. Okay, and now why I said possibly one more step is because if your solutions ever meet, then you can compress the two solutions into one. Then we write it as the lower bound less than equal to x less than equal to 4. This is a standard form. The standard form is your lower bound less than equal to x less than equal to your upper bound. And the bounds are given here by the solutions. Okay, so we can only do this compression if our solutions meet here. Sometimes they don't meet. Sometimes you get two solutions going in opposite directions, kind of like this graph. Let me find out this graph here. Two solutions going in opposite directions, so we can't compress the solution. If the things meet, like this graph here, the example we just looked at, this is the same solution, then you can compress it into the form of the box in red, right? What we've just done above. Yeah. Okay, so just note, because sometimes you get an extra mark or two for noting whether you can compress a solution or not. Okay, and then this other example, x greater than, absolute value x greater than 3. So if you guys will note here, okay, again, this is the solution I'm looking at because I don't want to waste too much of time. But this one here, if you do the same thing, to solve it, you just take the positive version and the negative version. From the negative version, we do one more step. These are your two solutions, which is the same as what we have down here. Is it? Yeah, it is. Then you plot it on the number line and you'll get something like this. Open circles, obviously, and the solutions don't meet up. They go in opposite directions. So when that happens, you cannot compress it further. You leave it as two solutions. Okay. Here's just a summary of what I just said, showing you with your different bounds, what you can do. Okay, and now, again, guys, unfortunately, I don't want to spend too much because we should probably move on to something else. You guys can try these. Rational expressions. Okay, let me just explain this because this is important. It's very easy. It's one of the easiest things in the world. It just looks complicated. finding the domain of rational expressions all comes from the idea that you cannot divide by 0. Once you see division by 0, then we know our fraction is broken, essentially. Right? Once you divide by 0, things go wrong. So you see the denominator here is x minus 4. When we're finding the domain of an expression, which is what this whole section is about, finding the domain means finding the allowed x values. So the allowed x values here will be any x value except the one that makes the bottom equal to 0. Right? So we always can write this as an equation, right? X minus 4 is equal to 0 because we know that's not what we want. So solve for x here. Find the value of x using our rules that we learned above, how to solve equations, and we get x is equal to 4. So we know when x is equal to 4, the bottom here is equal to 0, right? We can see if you plug 4 into this, we get 4 minus 4, which is 0. That means this value we solved for is something we don't want. So the domain is written like this. X is an element of real numbers, comma, x not equal to 4. Right? It's as simple as that. That's all you need to do here. So again, to go over it, you just need to take the bottom of the fraction, equate it to 0, and then solve for x. Whatever that x value is, you just exclude it from the domain. It's always the same form. X element of real numbers, x not equal to the values you just solved for. Okay. And I'm going to skip this example now because it's the same idea, but we haven't learned how to factor yet. That comes a bit later, so that example is out of place. Okay, but yeah, okay. I'll do another one like that in a moment. Let's look at this expression here. 5x squared over 25x, which you guys might agree with me, we can essentially, using our rules of exponents, cancel out 1x. Right? We learned that the last time, so I can write this as 5x over 25. Right? You can just recap the exponential rules if you need to. Now, these two expressions are equivalent, even though they seem to have different domains. Right? On the left, the denominator is 25x, and we can see here if x is equal to 0, then the fraction kind of blows up and we don't like it. So the domain of the left expression is x element of real numbers, but x is not equal to 0. Okay, same idea as what we learned before. This is always the way to find the domain. And on the right, there is no restriction because there's no x at the bottom. So here it's just x is an element of real numbers. Okay, now mentioning this because I kind of don't like it because there's an equals to sign between these two expressions, which means they are exactly the same. So how can they have different domains? Right? They shouldn't. They should have the same domain, but this is the way it is taught in the module manual, and I've seen them examine things where they ask you to find the domain of an expression before simplifying it. So if they ask you to find the domain of an expression before simplifying it, then don't cancel things out. So then you'll end up doing what's here on the left. Don't cancel out and then find the domain. If they just say find the domain, then you're allowed to cancel things out and do what's on the right. Okay, and honestly, that makes me a bit uncomfortable because to me, both are equivalent, and the one on the right should always be the answer. But again, just note, if they say don't simplify, or they say find the domain of the original expression, or anything along the lines that tells you not to simplify, then you do what's done on the left here. If they don't specify, then you can do what. Okay, but again, if there's ever ambiguity, guys, don't worry. Always look out for the slightest ambiguity, give you the benefit of the doubt, and mark it correct. Okay. So now this one at the bottom, if I can just do this one quickly, because this is a nice example. If you don't know how to factor later, you guys can look it up. But this one here at the top, we can rewrite the expression as x plus 3 over, let me think how I can factor this. I can write it as x plus 3 times x plus 9. Again, your calculators can do this for you guys if you want to, or you can always look it up, but we will learn how to factor later. Okay, and the instructions are further in the notes here. Okay, so now from here we can cancel out x plus 3 on the top and at the bottom, and we're left with 1 over x plus 9. then the domain of the new expression here is just x is an element of real numbers, but x cannot be equal to -9 because -9 makes the bottom equal to 0. But if they asked you to find the domain of the original expression before simplification, then x element of real numbers, x not equal to -3, x not equal to -9. Because both those values in that case make this fraction, the denominator of the fraction, equal to 0. So again, be careful on how they word it. If they say don't simplify, do what's on the left. If they say simplify or don't specify anything, then you can do what's on the right. But again, I'll mark very leniently with these things because it's not always clear the way the question is written. Okay, and unfortunately, guys, it's 7, so I'm going to stop at this point. We've covered most of the important things, and next time we will just go straight into the ICE task and learn more important stuff from those examples. Okay, so I'm going to stop the video at, actually, no, maybe I shouldn't, because I'm going to be here for another few minutes. If you guys have any further questions, any things you want to know. Yeah, so this is the time, guys. The floor is open for you. If there's anything at all. Jared, yes.
Sorry, sir. I know I'm talking a lot today,
No
but
problem.
so you see this example that we just went over, right?
Yeah.
So let's say we get one, for instance, on the top, we're going to go 2 over x to the power of 2 plus 4x plus 4. I know that should give you the same, like, factors in the end. So it's going to be x plus 2 to the power of 2. I mean, would we do that the same way as that?
You mean canceling factors out in that case?
Well, so if the factors are equal to each other, if they're exactly the same, then would it just be like, can I actually just like the one that you're given in an ICE task? I think it's 4.2.
4.2. Okay, let's have a look. ICE task 4.2. Yeah.
Because that will give you the same factor, like the two brackets, which should be the same.
Okay, so we can, let me just see if I know what you mean. So you're saying I can pull out.
Wait. So one down, one more down.
Oh, so
4.2.
4.2. Okay.
Yeah.
Oh, so you're saying I can factor the bottom here.
And it should give you the same bracket.
Okay, squared. Okay, that's what you mean.
Yeah.
Yeah, so here it's probably exactly what you're saying, x not equal to -2, just
Yeah,
one of them.
-2. Yeah. Okay, no, then that's perfect. I just wanted to know if there wouldn't be this, but I see it works.
Okay, all right, yeah, perfect.
Thank you.
Good question as well, because some people might write -2 twice here, which is not necessary.
Yeah, and then I've got one last question. So for
Sure,
this assignment, because I know it's coming up time for it to be due, I've noticed, and a lot of people have also said, question 3 is repeated in question 4, but question 4 has like one extra question. Is there any updated version of the assignment, or is it supposed to be like that, and then we just copy question 3 down into question 4?
There isn't an update yet. Oh, sorry guys, I haven't gotten to it, but yes, let me ask somebody. And if you guys can do me a favor, and can anyone just, I don't know, maybe on the WhatsApp of the assignment, if that's possible? Or is it a PDF?
Sorry, sir, you cut out there.
Okay, sorry. Can you hear me now?
Yes.
Yeah, so I was just wondering, do you guys, is the assignment a PDF?
No, it's a secured Word file,
Oh,
so we
crap.
can't share it or take screenshots or copy and paste it.
Yeah,
But I
okay,
mean,
so I
I
have to.
can print it out and take a photo for you if you would like.
Okay, we'll call that plan B, but let me check tomorrow when I go in, because I'm going in tomorrow, if I can, someone can help me to get access to this thing, because I haven't been able to see it yet.
Okay, thank you, sir.
Okay, all right. And guys, please remind me if by the end of tomorrow I don't do it, because it's going to be a busy day, but I'll time. Okay. All right.
Sir, can you hear me?
I can hear you.
I just wanted to ask the mission that you've given us. Can we do the same thing? Put it on paper, take pictures, and then submit it for both of those?
Yeah, that's perfectly fine. Pictures is perfectly fine.
Thank you.
You're welcome.